a specific tutorial on JAX. I've noticed that a lot of people have problems and trouble with JAX, specifically understanding it and kind of what it does, because it does a lot of different things. So the big thing I want to go through here is exactly what it does and just walk you through the functionality of JAX and all of the different individual elements that it does. Because once you understand those individual elements and what JAX is doing overall, then it's a lot simpler and a lot easier to wrap your head around. So the first thing, and I think the easiest way, like the highest level framing to think of JAX is that it is like a sub language of NumPy, right? And then meaning that it would be like, so you've got your base language of like C, right? And then within C there's C sharp and C++. And then if like C sharp and C++ come along, they have to do very specific and like really good things that C doesn't do, right? Because then it's like if they don't, if they're not massively groundbreaking on that level, then why not just use C, right? So like there has to be like something that is just very unique about like this kind of like sub language in this instance. And then so that's exactly where JAX comes in, right? So if you know NumPy arrays and you're familiar with NumPy arrays, like JAX like operates off of NumPy arrays. So there's like JAX recreates NumPy arrays. Like a JAX array and a NumPy array are the same thing. They function a little bit differently, right? Like it's just like a tiny tweak, but these tiny tweaks are huge and massive, which is why JAX is like really predominant, right? Like why you utilize JAX. And then so that's kind of the very first high level framing, right? The second thing to kind of understand at a high level is that JAX is reliant on Python as to like how exactly what these kind of tweaks are to the processing, like what it's doing specifically that NumPy arrays don't do. You need Python to do it, and I'll get into that. And then I think those are the kind of the two big things to get into this, right? So then remember, first of all, JAX is just operating off of NumPy arrays. And then if you're not familiar with what a NumPy array is, this very first cell, really self-explanatory, right? It's just an array of numbers. So 5, 10, 15, 20. That's my array, right? And then this would be a one-dimensional array of 4 numbers, right? And then it's breaking it down into like you're breaking down like a hierarchical graph, like you're inverting the hierarchy of a graph, right? Kind of, and then that's what you get out of like a NumPy array. And then you can combine multiple NumPy arrays, right? So I could have multiple a matrix of NumPy arrays, and then that gets into more complex things. But so within this, when I hit this play button here, right? I hit this, and then I get this output and this result. What is happening is that this whole entire array is pre-compiling, right? And then so that pre-compiling concept, if you're familiar with like applications, things like that, like a lot of those, like or web pages, things like that, they pre-compile, right? They preload, except for within Python, right? And then so that's kind of the and if you know anything about Python, like that's the big difference within Python, right? Is that like so Python is a translator, not a compiler, and then so whenever you're writing in any sort of almost any sort of programming language, it compiles into base code, right? Into like using assembly, it compiles into base code into zeros and ones, binary, and then that's what gets fed into the model, right? Like machine language, and then what? Except for Python, which is then it's interpreting on the fly, right? It's changing and interpreting for the machine what it should read it as a machine language, and it's called just-in-time compiling, right? And then so that just-in-time compiling aspect is what JAX does differently than NumPy. So when I click play on NumPy, it compiles and then it spits out the output, right? And then that's it, just a compilation, just a compiling process. And then here on this next cell, I've got an example where we're creating both a NumPy array and a JAX array. And then so with the NumPy array, we print out the first 10 elements. So 0, 1, 4, 9, 16, 25, 36, 49, 64, and 81. And then the total execution time. This is the total time it took to compile it, and again pre-compiling, right? Whereas with JAX, it's that just-in-time compiler, and then so what this just-in-time compiler does is it dramatically speeds up that compiling time, whereas the execution time gets up by a digit the very first time that we execute this JAX compilation code within an environment, right? But then, and then, so if I hit this every single time on the play button, it's going to execute it the first time every single time. But if you, one of the benefits is that, so you can see this massive, like a magnitude of difference in the compilation time for JAX, like much faster for compilation. It's just that execution. But then, so that execution penalty only happens again the very first time that you do it, but you still get that compilation reward. So you pay the penalty once and then get the reward all the time. So number one reason to use JAX right here, right? Like this is like a big reason to use JAX just in and of itself. And then so if this were all that there was, I think we wouldn't talk about JAX overall, right? But so like JAX does multiple things, which is again why it makes it confusing. But so let's break this up into individual components. Component number one, this is what JAX is doing, is that it's breaking up and it's doing that just-in-time compiling and that just-in-time compilation. And that just-in-time compilation is a literal order of magnitude faster on the execution time overall. And then you pay a execution penalty one time, but you still get that compilation reward every single time. And then so that's the benefit of it, is that over long periods of time and lots of executions and lots of compiles, JAX is like massively speeding up performance because it's utilizing TPUs and GPUs in this instance. So it's like the ingredients that JAX needs overall are essentially you need Python and then like NVIDIA cards or like TPUs, so like what Google puts out or any sort of a product like that. And then, so again, like JAX does more than just this speed up the compiling, right? The next thing that JAX does is there's kind of three things overall. So number two is that JAX has a built-in function called grad, and it's for gradient descent, right? And then so if you're familiar with mathematics, essentially what this function does is it massively speeds up your ability to calculate gradient descent functions. And then so let's look at like these two cells here, right, that I have up here on my screen, this first one and the second one. And then there's a few things and a few differences that you can see between the first cell and the second cell. The first one is that we do get like an actual approximation, right, 10.0. Whereas with the second cell, we're putting in and we're asking for an approximation, but we're actually getting like, we're not getting a full approximation. We're getting like if we cut it off at like 3, 4, 5, even 6 decimal points, then we get an approximation. But the big thing to point out is that like essentially with this second one, if you're intuitive and you're looking at it, we're like approximating an approximation. Like we're making this approximation. We're making it up basically because it's not actually approximating, right? Like it's just that we're creating it so that like it's such a small number that anyone would think it's 10.0, but it's not actually 10.0. We're calculating it out, right? Whereas with the JAX calculation, it's actually 10.0. And then the second thing is that you can notice that the math is far simplified with the JAX equation. So you see this, we have the define my function, and then we've got the return and then our derivative, and then which is the grad function, the grad that we're importing, and then we print the derivative, right? And then so, whereas with this second one, we've got define my function, which is to return this mathematical equation, but then we have to define exactly what gradient descent is and what the gradient descent formula, like, so we have to do additional math within like the gradient descent equation, right? And then so what JAX is doing in this instance, if you know and you're looking at that equation, is it does the gradient descent equation for you. And then so this does two things. One, it's doing the math for you, right, which is very important. And then, but the second thing is, and it's like not as intuitive to look at, is that it's turning the gradient descent equation into a function. Define my function, return the function, calculate the derivative, equals grad. equals my function, right? It's turning that gradient descent derivative straight up into a function, which is important again, like when you want to do things with this uh, computationally within different equations and different things. It just makes it a lot easier and a lot simpler than having your like your equation not defined as a function. So uh, one, it's speeding up. It's again like that speed up in that performance, right? And so it goes back a lot to that speed up in that performance. But then there's also this additional benefit on top of that that you're getting out of JAX arrays. And then so there's one more big difference here between JAX arrays and NumPy arrays. And then the big difference is that so with a NumPy array, you can change the array, like you can modify an element within the array, like at any point, right? And then so you can see here what we've done. We've got our NumPy array, which is 1, 2, 3, 4, and then we're putting in a modification. So we're saying change and modify that second output, right? And then on execution, that's what we want to happen. And then so with our NumPy array, we do that, and then our result is 1, 10, 3, 4. And then the second part of this code is saying, okay, do that same thing for a JAX array. And then what we can see is we're throwing an error. And then so you might say, okay, well, like, that's bad, right? That's not that's something that NumPy can do that JAX can't do, and that's one way to look at it. So if you like, there's like reason why you still utilize NumPy arrays and JAX arrays. Like, why not just use JAX arrays? Overall, there's a few reasons, right? The first one is that you don't like if you eliminate Python from this equation, then JAX goes away. If you eliminate the TPUs and GPUs from this equation, then JAX goes away. But then more specifically, there's certain times where you might want to modify your element post compiling or post execution, right? And so, but then there's also sometimes where you don't want to do that very explicitly, right? And then so having that ability to control that is very important. And then so do you want it to throw an error and then like it forces perfect code execution, right? So then it's either going to be this or like there's like post compiling, like there's not going to be anything that's going to come in and fix it, and then so you'll know that immediately, and then so it's cleaner overall, right, and a cleaner result. And then so what you do within JAX, if you want to modify the NumPy array, if you want to modify your JAX array, is you create a brand new JAX array. And then so as we're seeing in the example there below, so rather than saying like tacking onto the code and modifying it, you have to create the brand new JAX array with the output, and very specifically with the 1, 10, 3, 4 output. And then so it's just cleaner overall to lock it into this perspective. Like from a pure coding perspective, if you could go with option A or option B, like a lot of times you want option B, and you're going to want option B in more situations than you're going to want option A, just flat out. And then so unless the situation very specifically calls for option A, which is why both options still exist. But so overall, it's these three differences that make JAX unique from NumPy, and then it makes it stand out, right? Like why we talk about JAX, like we talk about like JAX again, going back up to the top, is the like C++ of NumPy, right? It's a derivative of NumPy. It needs NumPy to function. It modifies NumPy, but it modifies it in a few different ways. It makes it faster, it turns it into a function, and it makes it so that you can't modify the element on the fly. Those three elements, big things, are the ones that we cover overall. And then so those are kind of the three big concepts and the big things to keep in mind when you're talking about JAX, and then also keep in mind gradient descent and what it does specifically with that grad function and building that in there. And then now all of a sudden you understand JAX. So if you like this type of content, please like and subscribe. Thank you very much.